Hey everyone, welcome again. Today I'll guide you through writing and deploying your very own ERC20 token on Ethereum. We'll use friendly tools, no heavy coding needed, and walk you through each step slowly. By the end, you'll have a custom token on a testnet, viewable in MetaMask and on a block explorer. Before we begin coding, what is an ERC20 token? Let's explain ERC20 tokens in plain terms. ERC20 stands for Ethereum Request for Comment 20, a proposal that became the standard for tokens on Ethereum. Essentially, an ERC20 token is a cryptocurrency-like asset that lives on the Ethereum blockchain. Each token unit is fungible, meaning one token is the same as any other of that token. The ERC20 standard defines a set of functions like total supply, balance of, transfer, etc. So wallets and apps can work with any compliant token the same way. This standardization makes tokens easily interchangeable and compatible across wallets and exchanges. In practical terms, think of an ERC20 token as your own cryptocurrency on Ethereum. For example, you might create a MyCoin for a game or a community. Thanks to the ERC20 rules, any Ethereum wallet like MetaMask and Exchange will instantly recognize basic properties of your token, such as its name, symbol, and total supply. First, let's gather our tools. We'll use the Remix IDE for development. It's a free web-based Solidity editor, no download needed. Remix lets us write Solidity code, compile it, and deploy to a testnet all in the browser. Alternatively, advanced users might use Hardhat or similar frameworks, but Remix keeps it super simple for beginners. You'll also need MetaMask, a browser wallet extension. MetaMask will hold our testnet ETH, Ethereum, and be the wallet that deploys the token contract. If you haven't already, go to metamask.io and install the extension, then create a new wallet account. Make sure you save your seed phrase somewhere safe. MetaMask will allow us to switch to an Ethereum testnet like Sepolia later and sign transactions. You'll need MetaMask extension, or another Web3 wallet. Keep it installed in your browser and create an account. Testnet Ethereum will use Sepolia for testing. You can get a free test ETH from a faucet. Now let's write our token contract. In Remix, click the File Explorer and create a new Solidity file, mytoken.sol. We'll use OpenZeppelin's ERC20 implementation, which is a well-tested secure library. This way we don't write all the ERC20 code ourselves, we just build on the standard. In your mytoken.sol, start with Pragma Solidity. This version tells Remix which compiler version to use. We import ERC20.sol from OpenZeppelin. This gives us all the standard token functions. Our contract mytoken inherits from ERC20. In the constructor we call ERC20 mytoken MTK, which sets the name mytoken and symbol MTK of our token. Finally, mint to sender and creates 1 million tokens and assigns them to the deployer's address, msg.sender. We multiply the token amount by 10 raised to the power of its decimals, which is 18 by default. To account for Ethereum's smallest unit, so 1 token is equal to 10 raised to the power 18 units. This single constructor does a lot. It sets up our token's name or symbol and mints the initial supply to our wallet. Because we inherited from OpenZeppelin's ERC20, all ERC20 functions, transfer, balance of, etc. are automatically included. We don't have to code them. And feel free to change mytoken and MTK to your preferred name and symbol. Just make sure the symbol is unique and 3 to 5 letters for clarity. With our code in place, we need to compile it. In Remix's left sidebar, click the Solidity compiler tab. Ensure the compiler version matches. Click compile mytoken.sol. If successful, you'll see a green check mark. If there are errors, double check your code. For beginners, a missing semicolon or brace is a common mistake. And fix any typos. Don't worry if errors show up at first. Just read them or ask Remix AI. And fix line by line. Next, we need some ETH on a testnet to deploy our contract. Since this is just practice, we use a testnet Sepolia. Testnets work like the Ethereum network but use worthless test ETH. You can get this free ETH from a faucet. Go to faucet website, for example, cloud.google.com. The faucet will ask for your wallet address. Paste your wallet address, then click the button to get faucet. I received an error because I already took it. Each account wallet address gets only 1 drip per day. Wait a few seconds and you should see some faucet in your wallet. This will be enough to cover deployment gas fees. If you don't see Sepolia in MetaMask's network list, go to MetaMask Settings, Advanced, and enable Show Test Networks. Then select Sepolia from the Networks dropdown. Alright, now we're ready to deploy. In MetaMask, confirm you're on the Sepolia network and have some test ETH. In Remix, switch to the Deploy and Run Transactions tab. Left sidebar, the Ethereum icon. For environment, select Injected Provider, MetaMask. This connects Remix to MetaMask. Make sure mytoken is the selected contract in Remix. There's a drop-down listing compiled contracts. Now let's move on to contract verification and verify the contract directly from Remix. Normally, verifying a multi-file smart contract manually on Etherscan can be very time-consuming. You have to flatten files, match Solidity versions, handle imports, and enter constructor arguments. It can get messy. Instead of manually verifying a multi-file contract, we used Remix's direct verification to save time and avoid errors. This makes the process simpler, faster, and more reliable. To verify a contract directly from Remix, we first need an Etherscan's API key. Without this API key, Remix cannot communicate with Etherscan to complete the verification. So we first need an Etherscan API key. Go to Etherscan and sign into your account. After we log in, go to your profile dashboard and open the API keys section. Create a new API key and copy it. Now go back and save this API key in Remix. On the left sidebar, open the settings icon. Inside settings, scroll to the OR standard section. Here in this section, paste your Etherscan API key and save your Remix ID. This step is important because Remix uses this saved API key to verify contracts on your behalf. Once the API key is saved, Remix will automatically submit the correct Solidity version, contract name, and all imported files. Now back to the deployment section, scroll down above the deploy button, you'll see a checkbox called Verify Contract. This checkbox does not verify an already deployed contract. It actually means that verify this contract on Etherscan immediately after deployment. But how does it work? When we add API key in Remix settings, check the Verify Contract box. Then click Deploy. Remix deploys the contract automatically, sends the source code and compiler settings to Etherscan, and verifies the contract right after deployment. So verification is deployment time only, not post-deployment. Common misunderstanding. Many beginners think, I can deploy now and later just check this box to verify. That's not possible. If the contract was already deployed without this checkbox enabled, Remix cannot go back and verify it. You must either manually verify on Etherscan or redeploy the contract with verification enabled. Now let's deploy the contract. Click Deploy. MetaMask will pop up a confirmation window asking to confirm the transaction. You'll see details like the contract name and gas fee. Click Confirm. MetaMask will process the transaction. Wait a moment, it takes some time. MetaMask will process and verify our transaction on a blockchain. Once it's mined, you'll see your contract under Deployed Contracts in Remix. And your MetaMask will have spent a tiny bit of ETH. Congrats, your contract is now live on Sepolia blockchain. In Remix's Deployed Contracts panel, click the drop-down arrow next to your token's name. You can test some functions. Click the name to see the token name, click the symbol to see the token symbol. These are read-only functions are free to call. You can also try clicking balance of, but before we check the balance of function, we first need to mint some tokens. The balance of function only returns a value if tokens actually exist in an address. Since no tokens are created by default, we must call the mint function first. The mint function is a write function, meaning it changes the blockchain state and requires a transaction. Once the mint transaction is confirmed, the tokens are created and assigned to the selected address. After minting is complete, we can then call balance of, which is a read function, to check the token balance without sending a transaction. Scroll up and copy your address and click again. You should see your address has the full 1 million tokens. After deploying, you can view your token in MetaMask. In MetaMask, go to the Here Tokens tab, scroll down and click Import Tokens. Now select the Sepolia network because we deployed the token on Sepolia, and wait a few seconds. Next, paste your contract address and then type your token name, which in our case is MTK. Click Next and then Import. Now your token balance will show up in MetaMask under Assets. This is a fun moment. You'll see all 1 million MTK in your wallet. Alternatively, to see the token on Etherscan, search your contract address again. On Sepolia Etherscan, under Token Tracker, you'll see your token name and symbol. Click it to see details, total supply, holders, transfers, and more. Click on the Contract tab. If you see the green check mark with contract source code verified, that means the verification was successful. Now anyone can. Read the smart contract source code, interact with the contract directly from Etherscan, and trust that the deployed contract matches the published code. Great job. You've written a Solidity contract for an ERC20 token, set up MetaMask, got test ETH, deployed to Sepolia, and even verified your code on Etherscan. We covered a lot. Remember, this was on a testnet. The ETHs and tokens are for practice only. If you want to take this further, you could try deploying to the Ethereum mainnet with real ETH or another network, and maybe share your token with friends. Always be careful and learn about auditing if you're creating tokens for real use. Thanks for watching. If you found this tutorial helpful, please like and subscribe for more dev guides, drop any questions in the comments, and happy coding.